In this video, we'll learn how to balance equations, chemical equations. So we can start with hydrogen peroxide, H2O2. And when it decomposes, it turns to O2, gas, and water, liquid. So right here, we would want to balance chemical equations because hydrogen peroxide is H2O2. It won't turn it into 3 oxygens, so you need to balance out the equation. So we can start with multiplying this by like adding two hydrogen peroxides, which will bring it to 4 hydrogen ions, and then you just double this as well. So right here you have 4 hydrogen, 4 hydrogen over here, and 2. That adds up 4 oxygen ions, or oxygen atoms. So basically balancing equations is just conservation of matter. Like atoms aren't created nor destroyed. So you need to balance to follow this rule. Alright, over here we have aluminum bromide plus potassium sulfate. So in this, we'll go to potassium, bromide, and aluminum sulfate. Yeah, this is just a simple double replacement reaction, but as you can probably notice, this equation isn't balanced. So typically, we can start by the sulfates. So just 3 over here, and that balances the sulfates, and you can add 2 aluminum, which balances out. That's 6. Yep. So just like that, this equation is balanced. So for our next equation, we have phosphorus plus diatomic oxygen, which is O2. It goes into triphosphate, which goes to diphosphate, pentaoxide. Yeah. So I would start by multiplying this diphosphorus pentaoxide by 2 because this oxygen is a odd number. So yeah, there's 5 and 4. That's balanced. So over here we have barium chloride and sodium sulfate, and this goes to sodium chloride, which is salt or table salt, and barium sulfate. So right here you will need to know the charge of polyatomic ions, or just typically knowing the charge for each ion would be helpful. In this case, you can probably tell that sodium has a charge of 1 plus. Let's write down a different color. So 1 plus, and a charge of 2 minus. So this would be helpful when you're balancing equations. Since barium has a charge of 2 plus, it just cancels out. So you only need 1 barium for each sulfate. So let's get balancing. So right off the bat, you can see that there is 2 chloride and 2 nitrogen, 2 sodium So you can just put a 2 in front of the sodium and chloride. And I think this is balanced. Yeah, it is. Alright, let's balance this equation. So right here we have NaCl plus silver acetate. I think that's what it's called, yeah. And it goes to sodium acetate plus silver chloride, yeah. So this is kind of like a trick question because I actually realized all these coefficients or subscripts are just 1. I mean, other than acetate because it's like a polyatomic ion. So yeah, this is already balanced. Yeah, these questions are nice to come across, but yeah, you just gotta know. Alright, in this equation we have magnesium hydroxide. Yeah, hydroxide plus phosphoric acid, because right here it's phosphate plus, it has a 3 minus charge. Let's write that down. 3 minus charge, and the H in front makes it an acid. This is water and magnesium phosphate. So how do we start? We can start by balancing out the magnesium. So there's 3 magnesium and 1 here, so you just added 3 over here, and you can just combine the number of H, which is, so 3 times 2, yeah, this number 2, which is 6 H plus, and wait, actually you can also add 3 hydrogen ions, which is 9 H plus total here. Okay, and there's this also, here you have 1 phosphate, but you have 2 here, so you just gotta double that, and you actually add 3 more, which is not 9 but 12 H plus, and you have 6 O, 2 minus here, so your coefficient here will be 6. Alright, here's another way how can you solve this problem. So you can just start by writing out how many of each individual atoms are there. You can just, I recommend splitting apart H and O's, but like keep these polyatomic ions like phosphate. So there is 1 magnesium, there are 2 O oxygens, and there is 5 hydrogen, and 1 P phosphate. So on this side there are 2, excuse me, hydrogen, 1 oxygen, 3 magnesium, and 2 phosphate. So what you would do is, since they're like needs to balance, you want to have the same number on each side. So you can start by getting the same amount of phosphates. So you should just multiply this by 2. So now you need to change this number, which is you add 6, or just add 3 more to this, so it equals 8 H. And you also need to get the same amount of magnesium, which is 3 on this side and 1 on this side, so times 3 Mg. So add 3 as a coefficient, and just gotta times these out. So you would need to add 4 more hydrogen and 4 more oxygen. So it goes 12H and 6O. So times 6, and that's the same coefficients as we had earlier. So yeah. Alright, we can, we're moving on to balancing in acids now. So just to remember, the only thing you can add when balancing in acids are water molecules, H2O, and electrons, because balancing electrons is very important as well, and hydrogen ions, or just H plus. Because if you're like balancing an acidic solution, you have excess water because you're like balancing with water. So when balancing acidic solutions, you would typically want to start with half reactions. So right here, you can just take this chromium dichromate and a chromium ion. So you want to like start somewhere in the middle, because balancing acids and bases, you need to have a decent amount of space. So Cr2O7 2 minus goes to chromium 2 plus. So let's start with the balance, finding the electrons, like which one, like is this a reduction or oxidation reaction? So as you can know, this is good information to know. Oxygen typically will have a 2 minus charge, with a few exceptions, such as hydrogen peroxide. Like we know that is oxygen only has like a 1 minus charge. So in this case, oxygen has a 2 minus charge, but not because of this, but because just in general, oxygen has a 2 minus charge. So this will add up to 14, but you have a 2 minus on the outside, so it'll be a 12 minus total, or 12 minus total. And then since you got 2 chromium, you gotta split that between the 12 minus, so it'll be a 6 plus charge total. But right here you only have a 2 plus charge, so you need to have plus 4 electrons, to get to the 2 plus charge. So the next step is balancing out the oxygens. So right here, you got 7 oxygens. Like, how would you balance that? Like, how? So what you do is, remember how I said earlier you can add water and hydrogen ions? So water, surprisingly, contains an oxygen. So you need to add 7 water molecules. 7. And then this will be balancing out the oxygens, which is, this needs to balance out the hydrogen. It's plus 14 H plus. So the next one, it will be HNO2, which is nitric acid, goes to nitrate. So in this equation, there's a 1 plus, so there's like already a minus here. So it would be 3 minus for the nitrate, nitrite, and this will be a 5 minus for the nitrite. So right here, you need sorry. This will be a 3 plus, 5 plus. So you would just add 2 electrons here, and it just starts to balance the oxygen molecules. Since this is 2 and this is 3, you just add 1 water molecule right here. So that will combine to 3 plus 3H plus. And this should be pretty much it, And since this has 4 electrons and this has 2 electrons, let's multiply the bottom by 2. And after that, just like combine all these together and cancel out if you need to. So you got 14 H plus. You don't include the electrons because it's balanced. You got dichromate 2 minus, and then so plus 2 water plus 2 nitric acid, and then this all reacts to chromium 2 plus I'm gonna just go down here, 7 water and plus 2 nitrates minus and plus 6 H plus. Alright, so I can just erase this top. Let's move this up here. So since we have 2 hydrogen ions up here on both sides, we can just cross out, and that will lead us to 8 hydrogen ions. So plus chromate, dichromate, 2 minus, plus, you can just cancel this H2O, which leads to 5 water, plus 2HNO2 goes to chromium, 2 plus, and plus 2NO3 plus 5 water, and 3 minus. Yeah, this should be your balanced equation for an acidic solutions. Sorry, this is like a bit messy, but yeah, acidic just takes more steps. And that's the end of the video. Bye guys.